Alright, so in this example, we are given two functions. We are given the function g of x, and g of x says whatever your input is, you're going to subtract 2 from that input, and then you're going to square whatever that quantity is. And we've got our function f of x, which says whatever your input is for this function, you're going to multiply that input by 3, then subtract 6, divide that whole quantity by 5, and whatever that ends up being, you'll add 4 to it. To be quite frank, I think something that might be helpful is instead of using this variable x, you could just as well write this function as f of input. Whatever you put into f, right, 3 times that input, minus 6 over 5 plus 4. Now that seems a little bit silly when we're talking about specific numbers. Like if we had x equals 2 or 5 or 8 or negative 7, I mean, you could just substitute that number for all your variables in your equation. But that's really helpful when we start doing things like f of g of x. What does that mean? This means we are going to apply the function f, and its input is going to be this entire expression. And so that entire expression is going to make its way in and substitute for that variable x in f's equation. Something I like to do is to say, well, if I'm going to apply f to the input, and our input is g of x, I quite literally substitute g of x for x everywhere in my equation. And so we could write this quite literally as, well, this is going to end up being 3 times g of x minus 6 all over 5 plus 4. We have quite literally substituted this expression, just g of x, in for our variable x in our function f. Okay, well now we can go ahead and say, well, what is g of x? We can actually go ahead and write out this expression instead of just writing g of x. Okay, so we can write this as, well, 3 times x minus 2 quantity squared minus 6. Actually, I'm going to do this in black so you can see exactly what's going on. All over 5 plus 4. And so here's our composition function, f of g of x. Awesome, awesome, awesome.